Hello MAT 117 College Algebra students. This is Math Coach Colin, and this is a review video for some topics in Objective 12 I noticed that a majority of students have not yet completed. The first topic we will go over is combining functions, advanced. In this topic, you will be given two functions, usually called f of x and g of x, and you will be asked to either multiply the functions, divide them, add them together, or subtract them, and find the domains of these combined functions. To do this, you take the two functions and you do as instructed. Finding their domains is a little trickier. Remember the table provided in ALEKS. If A equals the domain of f of x and B equals the domain of g of x, for addition, subtraction, and multiplication, as shown here, these three parts on the table, the total domain of the combined function is the intersection of A and B. The upside down U, right here, means an intersection. For division, it is the same. It's still the intersection of A and B, except that you exclude the values of x that cause g of x to be 0. That's what that means here. The values of you get rid of the x values that cause g of x to be 0. This is because when you divide f of x and g of x becomes a denominator of a fraction. And you don't want g of x to equal 0 because when a fraction equals 0, that's undefined. So any values of x that cause g of x to be 0 must be excluded from the domain. Let's look at an example problem. You have f of x equals 1 over 3x squared plus 5, and you have g of x equals 1 over the square root of x plus 2. Find f plus g and f times g, and then give their domains. Let's start with f plus g of x. Add f and g together, written as 1 over 3x squared plus 5, plus 1 over square root of x plus 2. This is the combined function. Now we have to find the domain. We have to first find the domain of f and g individually, and then we intersect them, as seen in the table for two functions added together. For the domain of f, we have to avoid a denominator of 0. But the denominator of 3x squared plus 5 cannot possibly equal 0. So the domain of f is negative infinity to infinity, in parentheses. For g, the denominator can't equal 0 as well. And a square root cannot be negative. So we set x plus 2 is greater than 0, and then we solve for x. Performing this algebra, we see that x is greater than negative 2. And this is the domain. In interval notation, we write it as negative 2 to infinity. Also in parentheses because we have x is greater than negative 2, not greater than or equal to negative 2. If there was an equal symbol, then we would use a bracket. But because it's not included, we use the parentheses. To intersect these domains, we write the final domain as the domain that best includes both of these domains. This is negative 2 infinity because this is included in both domains. Now we find f times g of x. Multiply f and g together as 1 over 3x squared plus 5 times 1 over square root of x plus 2. This results in 1 over the quantity of 3x squared plus 5 times the square root of x plus 2. The combined domain applies the same rule we used for f plus g. So the final domain is again negative 2 comma infinity in parentheses. This is our final answer for combining functions advanced. And now the next topic we will go over is composition of two rational functions. In this topic, you will be given two rational functions, f of x and g of x. You will be asked to find the composition of the two functions, usually f of g of x, and you will be asked to write the domain of the recomposed function. Let's look at an example problem. You have f of x equals 5 over x plus 2, and g of x equals 1 over x. Find f of g of x, and find the domain of f of g of x. For this one, we are not multiplying f and g together. We are finding the composition. If you are asked to find f of 5, for example, you would substitute 5 in for x in f of x, and you would solve. Similarly, if asked to find f of g of x, which is what you are asked to do in this problem, you substitute g of x in for x into f of x and simplify. Therefore, f of g of x looks like 5 over 1 over x plus 2. See here, g of x is equal to 1 over x, so we took 1 over x and put it in for x into f of x. To simplify, if you multiply the whole thing by x over x, you will then have 5x in the numerator, and then for the denominator, if we distribute the x into 1 over x and the 2, this simplifies to 1 plus 2x. So our final composition is f of g of x equals 5x over 2x plus 1. To find the domain, we have to exclude a value of x that causes the denominator, 2x plus 1, to be 0. That is negative 1/2. Then, we need to also remember that when we originally plugged in g of x into f of x, we had 1 over x in the denominator as well. So we need to exclude the value of x that causes 1 over x to be 0. That is 0. So we exclude negative 1/2 and 0 from our domain. Other than these, the rest of the domain is all real numbers. Therefore, the domain is negative infinity to negative 1/2 in parentheses, union with negative 1/2 to 0 in parentheses, and union with 0 to infinity. With this topic, remember that when you find the domain, you have to exclude x values that cause the denominator of g of x and the denominator of f of g of x to be 0. This is because both of these are included in the denominator of the composed function. The next topic we will go over is quotient of two functions, advanced. In this topic, you will be given two functions and asked to divide them and simplify. Then you will be asked to find the domain of the new function. Let's take a look at an example. Say you have f of x equals x minus 2 over x plus 4, and you have g of x equals x over x plus 4. Find f over g of x, and then find the domain of f over g. Remember the rule when dividing by fractions. You multiply by the reciprocal. So when we divide f of x divided by g of x, or taking x minus 2 over x plus 4 divided by x over x plus 4, we write this as x minus 2 over x plus 4 times x plus 4 over x. See, we took the reciprocal of x over x plus 4 becomes x plus 4 over x. See here that the x plus 4 can cancel out because x plus 4 over x plus 4 becomes 1. And so our final answer is f over g of x equals x minus 2 over x. To find the domain, we need to note that the domain of f over g can contain only numbers that are in both the domains of f and g. Because the denominator of f is 0 when x equals negative 4, the domain of f is all real numbers except for negative 4. Or that just means we exclude negative 4 from the total domain. In the domain of g, we also exclude x equals negative 4. So x equals negative 4 needs to be excluded. So x equals negative 4 needs to be excluded from the domain of f over g. We also need to find x values that cause the denominator of f over g, which is g of x, to be 0. G of x equals 0 when the numerator is 0. We see that g of x is 0 when x equals 0. So we also need to exclude 0 from the domain as well. Again, we are excluding negative 4 and 0 from the domain of f over g. This means that the total domain of f over g is negative infinity to negative 4, union with negative 4 to 0, union with 0 to infinity. These are the final answers for this problem.